Following on from a previous vision space presentation, retinal decoherence and the research proposition, we can perhaps look a bit closer at the role dark matter could be playing in sensory perception. Dark matter remains dark because our approach to the nature of matter, and hence the design of equipment, is not commensurate with the task. Conceptually, we haven't got there yet, so we can hardly expect that our instrumentation will do the job. If we're going to break this impasse, then we're going to have to first understand what's amiss with our general approach. How can we approach an understanding of our own shortcomings at the conceptual level? The answer is, as always, revert to the perceptual level and the ontology of the experiential. As Da Vinci understood, all knowledge has its origins in perception. Vision is fired up by microparticles. There are facets of vision that we simply can't approach and remain beyond our understanding and therefore out of reach of our current conceptual model. If we could develop equipment that functions in a way commensurate with the function of the retina, the visual pathways, and our presentations of vision, would we then be in a position to extrapolate and use that understanding to raise luminance levels elsewhere? In other words, do we see within vision evidence of the influence of dark matter? And if we were to understand in more detail how the visual system operates, would dark matter make more of an appearance to a new generation of instrumentation, and hence point the way forward? If dark matter is out there, what's it influencing? Photons, for example? Gravitational lensing effects over large distances due to the presence of dark matter is appreciable as we observe the universe through telescopes. In vision space terms, these records equate to an explicit take on reality. But what about the implicit, responsible for our spatial awareness and its in-time manifestation, responsible for embedding us in our environment? Are photons affected in an alternative way by the same force, leading to an independent expression capable of demonstrable effects over terrestrial distances? This implicit take on reality is something we can't observe or address in any simple way. Even on an experiential basis, it's extremely difficult to describe. It occurs to us, but it remains at best subconscious. It manifests as a simultaneously understood field, extending throughout phenomenal field, supplying the contextual spatial impression of the scene, the notional where. Into this field, our explicit take on reality manifests, through time, within central vision, delivering the notional what. How does this combined reality, appreciable in terrestrial phenomenal field, relate to that projected of the universe by our telescopes? And if it were available to us at that scale, to what use could we put it? We have currently not developed instrumentation to enable the dataset to be detected, let alone processed. It remains dark. Instrumentation design and optical data projection is not compatible with our presentations of vision, and consequently the technology's relationship with the real is not commensurate with our own. If that's the case, then it's pertinent to ask what its records actually mean to us. Stars fill so little of the observable extent of space and cover such great distances that a contextual view, helping to define the spatial settings of our terrestrial environments, might not provide much in the way of a perceptually useful impression of deep space. However, such a system may make an appreciable contribution to a visual encounter of galactic structures. The real benefit of developing both an explicit and implicit impression of the universe will be on our understanding of its basic makeup, the nature of reality and matter itself. Is there an alternative channel through which to perceive the universe that in turn indicates something fundamental about its structure, something that could give us new handles on the nature and function of dark matter? As discussed in other presentations, vision space indicates that we're taking something else from the light array or electromagnetic radiation entering the eye. This alternative offering being delivered from an independent configuration of data potentials requiring an entirely different processing methodology within the visual system. The assumption would be that what our instruments in the form of telescopes, etc., record and the basis of the data we use to perceive the world in central vision are of the same order. We are more conscious of this explicit take on reality in vision. So the mistaken assumption has been that essentially that's all there is to see as we look out in the universe. What else is there? The rest of what we observe in vision, i.e. what's going on in peripheral vision, being dismissed as just a degraded, out-of-focused version of optical projection, stuff to be ignored. The true nature of peripheral vision and the data structure occurring there are only beginning to be formally addressed by science. Even though it presents 90% of phenomenal field, it effectively remains dark and unapproachable. Even though in PAC we consider that it provides our lead proximity and orientation cues, constituting our primary sense of spatial awareness, we haven't, until vision space, attempted to replicate this function in our information display systems, and consequently they remain deficient. The data potential in terms of the signal, its detection and the processes required for manifestation have been explicitly stripped out of the observational apparatus as we take clear and noise-free records of and develop theories about the universe and the nature of reality. Consequently, the information that could derive from an implicit take on reality can't even begin to manifest to convey its contribution. We can only encounter hints of its existence as aberrations or artifacts appearing in mechanical records. Our instrumentation remains only partially sighted, missing if not avoiding, due to our approach that manifests in the design of our technology, an entire dataset pertinent to the formation of our relationship with the real and a better understanding of our universe. Our technology is essentially myopic. To substantiate such a view, we would be looking to find a means by which the presence of dark matter exerts an influence at a terrestrial level, as some kind of medium or ambient presence, in which we are embedded here on Earth. A dark photon source in the background, interacting with the particle photon entering the eye, and imparting information pertinent to the way dark matter relates to our spatial context. If we can understand visual process through modelling the structure of phenomenal field and carefully tracing this back through the brain structures to retinal function, we should be able to extract enough of an understanding to construct an awareness of the universe commensurate with terrestrial awareness, incorporating the full range of influences in play. From there we could extrapolate to some extent about why and how this is occurring to direct further experimentation. Our activities would be compliant with what's actually involved in an act of observation. Visual perception suggests that the datasets responsible for the production of phenomenal field require independent spatial scenarios that are essentially not relative. They simply don't and can't be made to align or unify. There would be a fundamental duality involved in visual process, deriving from the possible dual orientation that the electromagnetic radiation entering the eye has with respect to us as macro bodies. The duality of data potentials being dependent on the status of photons as free-moving microparticles with respect to the macro condition. The intersection between these diverse states of matter, micro and macro, forming a membrane within and throughout our universe. It would be an explicit encounter with the membrane revealed in gravitational lensing. We are missing the implicit. In the macro state, we have a direct relationship with the macro scale of matter. However, we only have an indirect relationship with the micro state, and the suggestion is that there are only a limited set of free-moving microparticles that intersect with the macro context. The rest remain dark and are not going to materialize for our current technology however much energy we throw at their manifestation. The reductionist approach would simply no longer be appropriate. The above would identify that even photons, together with dark photons, were essentially of the dark matter set, but intersecting with our macro condition as a specialist particle. If there is a fundamental duality with respect to matter in our universe, and photons had a foot in both camps, then photons, as our visual messenger, could hold two impressions of the macro condition, one as a microparticle interacting with dark matter photons, ambient and indirect, and the other as regular photons, directly intersecting with the macro state in particle form. This duality of data potentials would require us as a biological system to develop a membrane through which to handle the independent dual impression, then another to manage their integration, suggesting a reason for the evolution of mind. As scientists have established, but have been unable to accommodate within the objective ontology, we can't be directly objective about all matter in our universe. To fully address the universe, the suggestion is that we need to adopt an alternative approach, mirroring that of the visual system as it copes with the situation. We need to embrace the experiential ontology set out by our perceptual structure, which is, after all, presumably why we have evolved to perform the functions occurring within phenomenal field. The best way of doing this, to my mind, is to computationally model a scenario commensurate with phenomenal field, on the basis that the duality exists. Yes, this is speculative, but worth a try. The vision space system, such that it is at present, merely illustrates the structures and dynamic of information exchange taking place. I believe its further development and transition from an illustrative model with a commercial programming architecture to a generative academic architecture performing in accordance with both our scientific and experiential understandings of visual process and perceptual structure is of critical importance to our understanding of matter, space, and the nature of reality, extending far beyond its more obvious applications in our information display systems. We remain only partially aware of our universe. To understand it, we're going to need to address the full nature of perceptual awareness. We find ourselves once again at least suspecting that all knowledge has its origins in perception.